Students, today we will see about the numericals of chapter number 3 and the theory which is pending of a potentiometer that will carried out tomorrow. So today we will see about the numericals for a resistor. So we have seen a theory of resistors when resistors are connected in a series and parallel combinations. So here resistors R1 is equal to 2 ohm, R2 is equal to 4 ohm and R3 5 ohm are connected in parallel. So this is a parallel combination. So find its equivalent resistance. So to find the value of an equivalent resistance, we have the equation is 1 upon R is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So R1 that is 2 ohm, R2 4 ohm and R3 5 ohm. So if you put the values, so that is 5, 10 plus 10 plus 5 plus 4. So that is 19 by 20. So equivalent resistance R. This is the value of 1 upon R. So equivalent resistance R that is equal to 20 upon 90 is equal to 1.05 and its unit is ohm. So this is the value of equivalent resistance through this circuit. Now if the system is connected to a battery of 20 volt, if the system is connected to a battery of 20 volt, we have to find the value of total current, that is I, and the current through each resistors. Means we have to find the value of total current I and we have to find the value of current through each resistors, that is the value of I1, I2 and I3. So as we know that as per Ohm's law, that is V is equal to IR, and as we know that the potential difference in case of a parallel combinations it will be same. So V is equal to IR. So I1 is equal to V upon R1, I2 is equal to V upon R2 and I3 is equal to V upon R3. So V, that is EMF of the battery, that is 20 volt. So 20 upon 2 is equal to 10 ampere. Here 20 upon 4, that is 5 ampere, and I3 that is 20 upon 5, that is 4 ampere. So this is the value of current through each resistors. I1 is 10 ampere, I2 is a 5 ampere and I3 is a 4 ampere. So the total current, I, that will be equal to I1 plus I2 plus I3. So that is 10 plus 5 plus 4. So that is 19 ampere. This is a value of a current passing through the circuit. So here is the answer. So it's one of the easiest example. If in place of a parallel combination, if it is in series combinations, then also you can easily find the answer. Okay. So now we'll see the next example. Now next is, here Wheatstone bridge circuit is given, in which this is a battery having a 10 volt current I that is passing through these points. Let me take points. This is point A, point B, this is point C and point D. So that current I that is divided into I1 and I2 at point A. The resistors are given 100 ohm resistor, this is 60 ohm, this is 5 ohm and this is 10 ohm. Now when current I1 that will pass through the point B, so at that point B, from current I1, Ig current that will passes into this galvanometer, and here resistance through this galvanometer that is given as a 15 ohm. resistance through this galvanometer, that is given as a 50 ohm. Yes, so that current I1 is divided into Ig. Okay, so here the remaining portion will be I1 minus Ig, that will pass from point B to point C. Same way here, current I2 is passing from A to B, and else the current Ig is passing from B to D. So from D to C, the total current passing, that is I2 plus Ig. So finally at point C, we have I1 minus Ig plus I2 plus Ig, that is equal to I1 plus I2, and that will be equal to I. So that current I is passing from point C, and that will again passes to the battery. So here in such kind of numericals, we have to consider Kirchhoff's lump rule. Okay, I hope you know the Kirchhoff's lump rule and how it is applied to the different circuits. So I am applying Kirchhoff's lump rule for A, B, D, A. Same way, I will apply it for B, C, D, B, and I will apply it for A, B, C, A. Okay, so applying Kirchhoff's lump rule for which circuit? That is A, B, D, A. So for A, B, D, A, I am taking a clockwise directions as the direction of my journey through the circuit. I am taking a clockwise direction for all the three circuits. So here, as the direction of journey and direction of current through the resistors both are in the same direction, so I will take minus 100 I1 from B to D. It is the direction of current through the resistors and direction of journey through the resistors both are in the same direction, so that will be minus 15 Ig. And here the direction of a journey and the direction of flow of current through the resistors both are in the opposite direction, so that will be plus 60 I2, that will be equal to 0. So if I divide this equation by 5, so I will get minus 20 I1 minus 3 Ig plus 12 I2 equal to 0. This is equation 1. Now for second circuit, that is BCDB. For this circuit, again I am taking a clockwise direction. So B to C, the direction of current through the resistors and the direction of journey through the circuit both are in the same direction. So I1 minus Ig into 10. Here the direction of current through the resistor, that is in this direction, and direction of journey through the circuit, that is means both are in the opposite direction. So plus I2 plus Ig into 5, and this is also the direction of current is in this direction, and direction of journey through the resistor, direction of journey through the circuit both are in the opposite direction. So plus 15 Ig equal to 0. So if I will simplify this equation, so 10 I1 minus 10 Ig plus 5 I2 plus 5 Ig plus 15 Ig equal to 0. So 10 I1 Ig, that is 15 plus 5, 20 Ig minus 10, that is plus 10 Ig plus 5 I2 equal to 0. If I divide this equation by 5, so 2 I1 plus 2 Ig plus I2 equal to 0. This is equation 2. Now, going for our third circuit, that is ADCA. For ADCA, for this circuit, again we are taking a clockwise directions. So this is the clockwise direction of journey through the circuit. So A to D, the direction of current through the resistor and the direction of journey both are in the same direction. So minus 60 I2 from D to C. Again minus I2 plus Ig into 5 and C to A. Here we have the voltage of battery is provided, so that will be the plus to minus, so that will be plus 10 equal to 0. So the equation will be minus 65 I2 minus 5 Ig plus 10 equal to 0. So I can write this equation as okay, if I divide this equation by 5, so 13I2 plus Ig equal to 2. Okay, so I am taking these values on the right hand side and 10 as it is. So this will be my third equation. Okay, so I hope up to this it's clear to you. Okay, so if you want, you can take a screenshot of these things, or otherwise I'll attach the PDF of the same same screenshot to you. Okay, so we have these three equations: equation 1, equation 2, and equation 3. Now we'll go ahead with okay. Sorry, to derive this equation number 2, just a little mistake was being made. Just for a sign convention, I'm just repeating the same thing again. So we considered the circuit B, C, D, B. Okay, and our journey through the circuit, that is a clockwise direction. So both the direction of current and the direction of journey through the circuit both are in the same direction. So minus sign will be there. So minus 10 into I1 minus Ig. Here the direction of current and direction of journey both are in opposite direction. So plus I2 plus Ig into 5, and here again the direction of current and direction of journey through the circuit both are in the opposite direction. So plus 15 Ig equal to 0. So minus 10 I1 minus plus 10 Ig plus 5 I2 plus 5 Ig plus 15 Ig equal to 0. So it will be minus 10 I1 plus 5 I2 plus 13 Ig equal to 0. So if we remove this part, so that will be minus 2 I1 plus, or minus 2 I1 plus, or if I take this minus sign, okay, minus 2 I1 plus I2 plus 6 Ig equal to 0. So I can write it as a 2 I1 minus I2 minus 6 Ig equal to 0. That will be the equation number 2. So I am writing that equation number 2 over here. That is 2 I1 minus I2 minus 6 Ig equal to 0. So now we have these three equations with us. Okay. Okay, so we have these three equations. Now we have to resolve these three equations. So this is equation 1. Equation 1, is it minus 20 I1? Let me check. 20 I1 minus 3. Okay, minus. Okay, so equation 1 and 2. So if I multiply this equation 2 by 10, and if I do the addition, means equation 1 is minus 20 I1 plus 12 I2 minus 3 Ig equal to 0. That is equation 1. I am multiplying equation 2 by 10. So that will be the 20 I1 minus 10 I2 minus 60 Ig equal to 0. So that will be plus plus plus. This will get cancelled. So 2 I2 and 63 minus 63 Ig equal to 0. So 2 I2 is equal to 63 Ig. This is your equation number 4. 2I2 is equal to 63 Ig, right? Now, I will put the value of this equation 4 into equation 3. So, putting values of equation 4 in equation 3. So, 2I2, in place of 2I2, I will write I2 is equal to 63 by 2 into Ig. So, 13 into 63 by 2 into Ig plus Ig equal to 0. So, from this equation, I will get the value of Ig, that is equal to 44.87, and here, okay, and the unit would be milliamperes. So this is how you can find the value of a current through the galvanometer using this circuit and by using Kirchhoff's law. I hope the equations and the methodology is clear to all of you. Once you understand the methodology, it's easy for you. It's not a big deal. Okay. So here we have completed the numerical portions because of the okay. And we have one theory left, that is a potentiometer, that we will see or carry out in our next class. Okay. Thank you.